say 15, 20 seconds. Okay, so balancing this equation, what we're basically saying there is the same number and type of atoms go into your reaction as come out of your reaction. So just counting them up to start with, I have 1 iron, 2 oxygens on my reactant side, and I have 2 irons and 3 oxygens on my product side. So it's not balanced right now, so I need to start messing with the coefficients to try and get it balanced. And the first thing I'm going to do is I'm going to put a 2 here, because it gets rid of my odd number, and these 2 are also by themselves. So by putting a 2 there, I'm now going to have 4 irons, and 2 times 3 is going to be 6 oxygens. So I put the 2 there, that gives me 4 irons and 6 oxygens. Then looking at the other side, well, if I need 4 irons and I have 1, I can put a 4 there. That's going to then change that to 4 irons. And I have 2 oxygens here, and I need 3.
6.
Oh, 6. I need 6. So to do that, I need to put a 3 there. And it's always a good idea after you balance an equation to just run through and check it one more time to make sure you didn't change anything unexpectedly. So 4 irons, 6 oxygens, 4 irons, and 6 oxygens. So this then is a balanced equation. Everyone agree with that?
Will the balancing of that be very similar to that for the exam?
Yes.
I don't know if there
I'm not. I mean, yes. Let's just go with yes. In terms of difficulty-wise, that would be, I would say, probably a medium level. Not super hard, not really super easy. And then balancing is just balancing. So that's how I think of it. So there you go. Okay, so now once you've got a balanced equation, you can start converting between moles. So that's where stoichiometry comes in. So anytime you want to change from one species to another, you're going to do that through mole relations. And that's going to be stoichiometry. So the easiest type of question we can do once we've got this is say if I have 12 moles of iron, how many moles of O2 are needed? So on your paper, figure out how many moles of O2 are needed to react with 12 moles of iron. To make sure everyone's getting started on the right path, this question is asking us to convert between moles and moles. So to do that, we're going to use the balanced equation. Okay, so the stoichiometry and the balanced equation is how we do that. So 30 seconds more, so to get your ideas down. Okay, so we're going to go through this step by step as usual, and the part given to us to start with is 12 moles of iron. And it wants us to find moles of O2. So we need a relationship between the two. Well, the relationship comes from your balanced equation. It says that for every 4 moles of iron, how many moles of O2 am I going to need? 3. 3. So for every 4 here, I need 3. If I start with 4 here, I can make 2 in the product. But this is just these two, so 4 and 3. So moles iron will go on the bottom. Moles O2 on the top. And then the numbers will be 4 and 3 for that. Therefore, moles iron cancel, moles O2 match. Doing the math, 12 times 3 is 36. Divided by 4 is going to be 9. So to react with 12 moles of iron, I would need 9 moles of O2. Does the process make sense? So when you're converting moles to moles, that is when you use stoichiometry in the balanced equation. It's the only time you can change from one compound into another, an element into a compound, or anything like that. Here, we're changing from iron into O2 in our problem. So the only way you can change from one thing to something else is by using moles. And that's the stoichiometry. So this is a little map I use to kind of keep track of things. Depending on where I am and where I start and where I want to go, it'll tell me what I need to do. So if I'm converting between moles and moles, that's stoichiometry. If I'm going from moles to number of atoms, which conversion is that? Avogadro's number. Avogadro's number tells me the number of atoms and molecules. Okay, so going from moles to that, and then going the other way is going to be the molar mass. Yeah?
So the number in front of the element refers to the amount of moles that you're using.
Yes.
Okay, so if you wanted to, like, you could multiply that by the molar mass to see how, like, the mass that you're using.
Yes, absolutely.
Okay.
I think you're absolutely right with what you're saying. So let's do another problem. And let's say how many grams of iron are needed to form 5 moles of Fe2O3. How many grams of iron are needed to form 5 moles of Fe2O3? So go ahead and give it a start. After about 45 seconds to a minute, I'll draw out the map to make sure we're all on the same page, and then I'll give you a little more time to do the math. Okay, to make sure we're all getting started the right path, we start out with moles of Fe2O3, and I want to get to iron. So the only way I can get to iron is by going from moles to moles. So the first step is going to be moles Fe2O3 to moles iron. And then once I've got moles iron, I can then go to grams of iron using my molar mass. So this first step is going to be stoichiometry. Then the second step is going to be molar mass. Or according to the map here, if I start with moles Fe2O3 here, I would go down to moles of iron, and then over here to the mass. So the first conversion is going to be stoichiometry, and then the second one would be molar mass.
Stoichiometry, that's when we use Avogadro's number?
Stoichiometry is the balance equation, the moles to moles. So like 4 moles of iron to 3 moles of O2. That's another 30 seconds or so. Okay, questions before I get started on it? No? You guys feel relatively comfortable with how you did? You want to see the answer first? Okay, so we're going to start with 5 moles of Fe2O3. And we need to go to iron, so the only thing we can convert to first is moles iron. So to do that, that's stoichiometry, so it's going to be 4 moles of iron on top. And the bottom is going to be 2 moles of Fe2O3.
I have a question.
Yes?
So did you put the 4 moles of iron on top because that's what we started with in the equation?
No, that's because what we're looking for here is moles iron. So whatever units here has to match with what we're looking for.
Gotcha.
And then the moles Fe2O3 has to cancel out.
So the bottom is
Bless you.
the bottom is what has to be right. Okay.
Yep.
Okay.
The bottom has to be matching with that, and then this has to be what we're looking for.
Okay.
So now 5 times 4 is 20 divided by 2 is going to give me 10 moles of iron. But at the same time, we're not actually looking for moles of iron, we're looking for grams of iron. So we need to do one more step and say that for every 1 mole of iron, we look to the periodic table. It's going to be 55.8 grams of iron. Mole will cancel, grams will match. And then doing the math, 10 times 55.8 divided by 1, it's going to be 558 grams.
Could you have did 60?
Yeah.
Instead of 55.8, okay,
60 is a bit of a stretch, but yeah, it's fine.
okay.
I prefer if you just rounded the whole number instead of the 10, but.
Wait, what?
Go to like 56 here instead of all the way up to 60.
Oh, no, that's what I meant, not 60. I meant to say 56, sorry.
Okay, yeah.
I'm sorry.
No, but if you did the, if you had this drawn out and you put 60 there, I would still be okay with it.
Okay.
You may have to catch me on it, but yeah. Because you're doing the process right. That's what I care about the most. Yeah.
I think this time I was able to figure out the process.
Okay.
I think I had issues identifying the ratio correctly. I had 4 moles of FE over 3 moles or 2. You get what I'm saying? It's
Yeah.
not the same ratio from others.
Yeah, it's from the other one. Well, the difference is that in this one, we're starting with moles Fe2O3, and we're going to moles Fe. Okay, so those are the two that have to be in here, because that's what we're relating. In the previous question, we talked about O2, and because of that, we had to put the O2 one in there.
So it's almost like the question will give away what the 2 parts of the ratio you should be looking for.
Absolutely, yes. That question will absolutely always give it away.
So when you're doing when you get the 55.8, obviously, you just do it of 1. You don't have to do it of how many there are.
No,
So
yeah, you
you're
do
not
it
going
of
like
one.
Fe2 would be like 100 and something.
Yep,
That's
it would
going
be
too
double.
far.
Yeah, because 1 mole is equal to 55. If you wanted to put 2 moles down there, you would have to double that.
That's, okay.
And 4 would be quadruple, and
Okay.
so forth.
But
Yep.
it has to be proportionate.
Yep, they have to be equal to each other, exactly. Yep. Other questions? Okay, let's try one more. How many moles of O2 are needed to form 7 times 10 to the 14th molecules of Fe2O3? We'll do the same thing. Go ahead and get started. In about a minute, I'll kind of draw out the map a little bit.
This is what's gonna be on the test, right?
Yes, this is the very last things that will be on the test. And I think I should also say, for most students, this is by far the most difficult things on the test.
You always have to put out.
Okay, so to make sure we're all on the right path here, we're starting out with molecules Fe2O3, which would be something like right here. So the first thing we're going to do is we're going to go to moles of Fe2O3. So that's going to move us over here. Then, after that, we can move down and go to moles of O2. So if I'm going from molecules to moles, what conversion is the first step going to be?
Molar mass.
No, AB.
Avogadro's number.
Avogadro's number. And if I'm going from moles one thing to moles something else, what's that conversion going to be?
No.
Stoichiometry. Moles to moles is going to be stoichiometry. So that's the plan. Let's see if we can do the math of it. Say 30 seconds or so. Okay. Any questions before I start working through it? Okay. So we're going to start with 7 times 10 to the 14th molecules. And we want to go to moles of Fe2O3. So to do that, we're going to say that 1 mole is equal to 6.02 times 10 to the 23rd molecules. So I do need a calculator for this. 7 times 10 to the 14th divided by 6.02 to the 23rd is, how much is it?
1
2, 3, 4, 5,
0
6,
times 10
7.
to the negative 9.
Okay. 1 times 10 to the minus 9th. Yeah, that looks right. 1 times 10 to the minus 9th moles of Fe2O3. Is that what you guys got? Everyone agree with that? Okay. Mine put it up in decimal form, so I was trying to count. Okay, that's you. Okay, so now we're in moles of Fe2O3, but it wants us to go to moles of O2. So to do that, we're going to use stoichiometry and say that for every 2 moles of Fe2O3, it's going to be 3 moles of O2 on the top. The O2 has to match with that, so we know that goes on the top. Fe2O3 goes on the bottom. So moles are going to cancel, moles match. In doing the math,
2 times 10 to the negative
2 times 10 to the minus 9. Yeah.
So anytime we start with molecules, just to be safe, just use Avogadro's number to go to moles and then go to whatever needs to go to next.
Yep.
If it's atoms or
Mass.
mass or whatever,
Yep.
just go to moles. So if it gives us molecules, just know to use Avogadro's number.
To go to
And
moles.
if it gives us moles, if it gives us moles, we just need to go like
If it's moles, then you have to look at what you want
What
to
you
do.
want to,
a little
okay,
bit
yeah.
more, Yep. But if it gives you grams,
Then you need to.
then
use
you're gonna go to
molar.
moles, the molar mass, yep.
Okay. So
This
if
is
you
why I
use
say,
atoms, Then I
you-
use, then
Okay.
you use what?
Avogadro's number.
Avogadro's
Atoms
number
and
too?
molecules are both Avogadro's number.
Okay.
So if it doesn't give you moles, you never go wrong converting to moles.
Right, okay.
So there you go. Any other questions about this?
Can you see that practice problem?
I can make some practice problems for you. I want to mention again that on Blackboard already, there are practice problems for 4 and 5.
Okay.
There are 2 sets that runs all the way through them. You can put up a couple more, it's not a problem at all. That you can work through and so forth. Any other questions about this?
No,
Yeah.
that last part of the equation, the 1 times 10 to the 99,
Yeah.
how would you put that in your calculator to figure out that last, the 2 times
2 times 10 to the minus 9?
Yeah, like how would I put that in the calculator to get that answer?
Oh, you have to do it yourself. You have to figure it out on your own. Like you have to count the zeros down. Is that what you're
Okay.
saying? How do you do that?
No,
Just-
I'm asking like how did you?
Yeah, the manually put in the
Yeah.
calculator? Okay. As soon as class over, come over, I'll show you. I've got to look at your calculator to see what buttons are on it. That's the only thing. Okay, the last thing I want to mention, I know we're out of time here, but I want you guys to just remember the shape stuff, where you make a dot diagram and then you look at how many lone pairs you have and how many bonding pairs you have, and then figuring out the shape. That wasn't on the quiz, but I wanted to remind everyone that there'll be a couple questions about that on the exam as well. There will be naming. Everything from chapter 4 and everything in chapter 5 up to and including stoichiometry. So defining ionic covalent, naming, predicting the formulas, finding the shapes and so forth, that will all be there to some extent. Yeah?
This is election day, will there be no office after?
Not on Tuesday. Not on Tuesday. I won't be here Tuesday. I'll be here other days though. So if you got questions or something, just stop by or shoot me an email, whatever. Yeah, I'll be around most of the week. I don't think I'll be here Tuesday. Okay, yeah.
Like I understand that it's the section of that one. But I can't, I don't know, I tried to put this part right here and just calculate it.
This shit out. I'm not fucking with this. Are you ready? This shit pisses me off right now.
How you feel?
I just learned this
Yeah.
last night, bro. Like, so,
Okay, so I would for it or anything, I would put that whole, this part into it.
just tell them what I'm supposed to be saying. Yes.
This is what happens.
He don't know. I can really cut his ass off and not have anyone worry about it. He just provides me.
Just look at it, but you could do that the night before.
I know.
Times 3.
Three times.
So, 3 divided by 2.
Not one.
So, because of where it is, 3 divided by 2, we know it's 1. So that 5 must be right there.
Okay, so then it just rounded up.
Yeah, so
Okay, that makes sense. I just, from where I could see it, I was like,
either 1 or 2.
okay, yeah,
I
I'm
think
looking
it's just
over.
because yours shows exactly 9 going across.
So it's not gonna show it. Okay.
Yeah,
That
no.
makes more sense.
No, cool.
Okay, I thought I was just getting the same thing and I started with numbers. That doesn't make sense.
Yeah, no, you're right.
This nigga said, yeah, I got you, baby girl.
Second,
Huh?
okay.
You might text him back telling him get out of lab.
No, you don't need to do that.
I don't need to do that.
No.
We're okay. So 6.02, gotcha, second.
Not 23.
23. And then times a random number. Got it.
So yeah, you don't need the caret. So the EE is the times 10 and then the caret for those calculators.
So if it's, what if it's like the 23rd power?
So if it's like, if you're trying to do 3 to the 23rd on here, that would be 3 carats 23. Got it. But 3 times 10 to the 23rd, all of this.
Oh, yeah.
So it's going to be 3 to the 23rd. The carat doesn't actually mean a superscript, even though that's normally what we think of it as, but it actually means the base and power. So it'd be like having 23 threes in a row, where this would be 3 and then 23 zeros. Forget that.
Why, for whatever reason, I was trying to manually do it. Now, I don't have it.
No, you don't need to. To do this, you don't need to. It may spit out in decimal notation, but you can just write down the decimal and do it fine.
Now, further, because you have 50 points.
Total, yeah. It's not.
If we didn't do that, I think it's gonna, I think I got a couple of stuff.
I think it's 50 points out of.
I think you next semester I'll do it.
Oh, yeah. Topic we can think about.
We're not very
Yeah, so I would choose either a popular topic, so you could do like or you could concentrate yeah, so kind of like, if you can choose a topic, and just start with the topic. Thank you for doing the work I should do.
I wash it all the time.
It's because I make a mess.
Well, no, it's because that spray that they have there is horrible. No. But if you clean it with water, then it erases it.
Oh, yeah?
Yeah. Not every time though, just clean it once, it erases every time without having to wash it.
Refresh it.
Yeah, yeah.
I promise, Dr. Russell, my doctor sent me it yesterday, and I forgot to send it to you.
Oh, no.
But I will tomorrow, I promise. My doctor.
I do all the cleaning at home. Actually, that's not true. I gave up recently and got cleaning ladies again.
It doesn't get any better as the kids get older.
I'm sure it does. I'm getting a feeling like I'm not doing a good job.
No. I don't want to say that at all.
We'll get out of your head on the floor.